NMR spectroscopy, 2 types of them. 13 carbon NMR, information about how carbon molecules are arranged. 1H NMR, how hydrogen and molecule are arranged. Now, now I realize this, I did do a bit much for like this. Now, if we look at this specification, students should be able to explain why TMS is suitable substance to the standard. Then the rest of it is application. Use this to suggest possible structures. Use integration data to do this. Use the N+1 rule to deduce a spin, splitting patterns, and the only way to get better at those 3 is past paper questions. Even if you have no understanding, do past paper questions. You'll eventually find some patterns. Actually, you will find patterns. After you do 2 questions, you will start to find patterns. And then in the real exam, you'll be able to spot patterns. And then I'm not guaranteeing you'll get 4 marks, but I'm guaranteeing you will at least get half marks. And like one of those big 6-mark questions, at least get 3 marks. So atomic nucleus with odd number of nucleons have nuclear spin, weak magnetic field, and nuclei are spinning in random directions. When a strong external magnetic field is applied to nuclei would align with the field against it, or will the field against it. Nuclei align with external field slightly lower energy over the opposed nuclei, single process of spin. And now I don't think the rest of this is on the specification. It really is not. No, it's not. Do I have my... No. Well, nuclei in different environments. And you might be wondering, oh, Imam, but these help you with understanding using... They don't, honestly, they're not. The only way you can understand what's going on is literally by past paper question, not these flashcards where it's just not even stuff that is in the spec. They don't want to test you on any of this. So let's not waste our time here. Okay, chemical shift. Now this is definitely what they want to test. The difference is relative to a standard substance. The standard substance tetramethylsaline, and the formula of this is SpCH34. Two key features of tetramethylsaline. The molecule has 12 hydrogen atoms in identical environments. It produces a single absorption peak. It's inert, doesn't react with the sample. It's non-toxic and is volatile, easy to remove from the sample. This one, 100,000%. You have to memorize this one. Number of peaks, yes, tells you how many different carbon environments are present. 1 peak for each carbon environment and molecule. Easy. What is responsible for the peak also? Interesting. TMS is added to test compound. Why? It could give you 1 marker, state why TMS is added for calibration purposes. And each peak on 1H NMR spectrum is due to 1 or more hydrogen nuclei in a particular environment. Numbers above peaks in 1H NMR spectrum tells you the ratio of areas under peaks, and the relative area under each peak tells you the relative number of hydrogen atoms in each environment. The N+1 rule, the peaks always split up into number of hydrogens on neighboring carbon plus 1. What is shown is the peak ratios, integration trace, and increasing in height are proportional to areas under each peak. Again, this is a flashcard that it'll never ask you on, and it honestly is slightly confusing. Like, all you need to know, N+1 rules, number of hydrogens on the adjacent carbon plus 1, and instead of peak ratios, integration trace. Yeah. Deteriorate solvents, you do need to know this. If a sample has to be dissolved, the sample solvent is needed not contain 1H atoms, and deteriorate solvents when the hydrogen atoms are replaced by deuterium or 2H. Deuterium, you do need to know deuterium. Deuterium is an isotope of hydrogen with 2 nucleons, proton and neutron, and CCl4 can be used as solvent because it does not contain any 1H atoms. Three reasons deuterium is used: because it's even number of nucleons, no spin, therefore does not create a magnetic field. Four types of peaks, and number of hydrogens adjacent carbon. Singular, doublet, triplet, quartet. Number of hydrogen adjacent carbon 0. Number of hydrogen adjacent carbon 1. Number of hydrogen adjacent carbons 2. Number of hydrogen adjacent carbons 3. Again, this is like something you would just know by just practicing a bunch of these questions. So I'm going to get rid of this as well, because you just need to memorize n+1 rule, number of hydrogen adjacent carbon plus 1. Well, a singular, well, it's going to be 0 plus 1. Doublet, 1 plus 1 will give you 2. Triplet, 2 plus 1 will give you 3. Quartet, 3 plus 1 will give you 4. So again, bit of a pointless flashcard again. Formula of RF. Now this is chromatography. The rest of the chromatography practicals I'm going to create posts to my playlist. But the RF formula: distance traveled by spark over distance traveled by solvent. And a mobile phase is when the molecules can move, always liquid or gas, and then the solid phase, or stationary phase, sorry, where the molecules can't move, must be solid or liquid on solid support. But yeah, NMR spectroscopy is literally past paper questions, guys. There's no other way to get about it. You know, it's not, I promise you, it's one of the only topics in chemistry where, let me just have a quick look at all the topics from year 2. Yeah, it's one of the only topics in chemistry where if you don't do past paper questions, you will not, I promise you will not get any marks in the exam. Because you just won't understand what to do. And what you'd be actually doing is you'd just be going through extremely difficult kind of questions. You wouldn't know how to do the type of questions AQA wants to ask for you. Yeah.